Hello. Right, this one is on proportion. First of all, we do direct proportion. There are two kinds of proportions, direct and inverse, but this one is direct proportion. This means simply that if you buy one fish and it costs £1, and you buy three fish, it would cost £3. If you buy 10 fish, it will buy £10. It will be cost £10, yeah? So the price you pay here is directly in proportion to the number of fish or the quantity of fish you buy. As long as in this kind of calculation, as long as there's the constant that the fish is always going to be £1. Yeah. So direct proportion means the more fish you buy, the higher the price you pay, and it's in direct proportion to the original price of one fish being £1. There's no buy 1,000 fish and we'll give you a discount or something. That doesn't come into it. It's just direct proportion. If you bought half a fish, yeah, according to this maths anyway, that would cost you 50p. See, it's still in direct proportion whether it goes up or goes down. And the usual way that they present these things in functional skills is with recipes. Recipe, yeah. And say you've got a recipe for, I don't know, 15 cakes. So for the recipe, you will need, I don't know, 150 grams of flour, um, I don't know, 5 eggs. I don't know whether this is going to work out, whether you could actually make something of this, and 90 grams of margarine. Okay, and it would, so it's all in direct proportion. The amount of the ingredients you need is proportional to the number of cakes you're going to make. So they might say, oh, well, how many do you need for 10 cakes then? What ingredients do you need to make 10 cakes? Because, as you know, if you look at a recipe in a book, online, wherever, it always generally gives you a recipe for 4 people or a recipe for 6 people. And you think, oh no, I've got loads of people coming round, so you need to scale up or scale down, depending on what you want to make. So the way to do this is always find for one. Yeah? Find how much of the ingredients you would need for one person, one cake. In this instance, it's a cake. So we do the flour, and we go, well, we need 150 grams for 15 cakes. So if we divide that by 15, we would need 10 grams per cake. And then we're making 10 cakes, so 10 times 10 equals 100 grams. So you just multiply it by the number of cakes you're going to make. If you were to make 50 cakes, then you would do 10 grams times 50. So it's in direct proportion. What about the eggs? So you need 5 eggs divided by 15. Oh, that's going to be an awkward number, isn't it? Didn't make this up. 5 divided by 15. No, 5 divided by 15. A third, isn't it, or something? It's a third. I'm going to leave that as a fraction. It's a third of an egg. Yeah. Now, we're going to multiply that by 10 cakes. A third of an egg times 10 equals, awkward number, 3 and a third, third eggs. Yeah, that would be the mathematical exact we'd need, but we'd probably just get away in the real world. Let's do 3 eggs, that'll do, yeah. Or just make it a bit more eggy, put 4 eggs in. The other one is the margarine. So we've got 90 grams of margarine make 15 cakes. So if we do 90 divided by 15, we get 6 grams per cake. Multiply that by 10 because we're making 10 cakes, 60 grams. Yeah. So find for one and then multiply it back out. Find for one. Right. So you're going to make some biscuits now. You're going to make some biscuits. And you can make 500 biscuits. 500 biscuits in, say, 4 hours. Right, so how many can you make, bear with me on the scribbly writing, in, say, 6 hours, part A, and we'll do 15 hours, yeah? Big long shift that is, yeah? So, find for one. Find for one. And in this case, finding for one means how many biscuits can you make in 1 hour. So 500 in 4 hours. So 500 in 4 hours, divide that by 4, you can make 125 per hour. So this one, part A, you're going to do 6 hours times 125. And part B, you're going to do 15 hours times 125. And that's pretty much all there is to direct proportion. Sometimes it's sort of hidden in the question. There's numbers all over the place. So 15 times 125, we're going to make 1875. Now, for that, you might get an extra little question at the end. Write down any assumptions that you've made. And the assumptions that you've made is that you will be able to keep up the same rate of biscuit making throughout the 15 hours or 6 hours. And also, your biscuits are all going to be exactly the same. If you're going to make different sized biscuits and you're going to start slowing down after a couple of hours, then this won't hold true. But those are the assumptions that you make. So let's have a look at some questions as we normally do. And you can pause this, have a go, and then play it and see if you get the same as me. Apologies, I made a mistake in one of the fraction questions, but I can't remember which lesson that was. It was 3, something like 4 3/4 instead of I think I put a 1/7 instead, but that's right. That's for you to hunt out and find. Make a comment so anybody else looking at this can say. Right, so Freya's making soup. She needs 500 carrots to make 1 litre of soup. How many grams of carrots does she need to make 1.5 litres of soup? Well, we've already found for 1 because 1 litre you use 500 grams. So they've done the first bit for you. So all we need to do now is the 500 times 1.5 litres of soup, which is 750 grams of carrot soup. Now, 1,000 millilitres of lemonade contains 250 ml of lemon juice. How much lemon juice does 600 ml of lemonade take? Find for 1. So we've got 1,000 divided by the 250. When you're finding for 1, it's always this second number there. That's 4. So it looks as though we need 4 millilitres of lemon juice in every quarter. Ooh, what have I done there? Oh, this is complicated, isn't it? 250 of lemon juice, 150 of lemon. So if we divide that by 4. Why did I divide that by 4? Divided it by 250. So that will be 4 mils of lemonade per mil of lemon juice. 4 mils of lemonade. This is written back to front, this one. So, don't like this one. They're written back to front. It's annoying. Yeah, page 44. 150. Right. So for every 4 mils of lemonade, we need 1 mil of lemon juice. Right, this is complicated. So now we're going to make 600 mils of the lemonade. So we've got to multiply that up by 600. So 600. So if we do 600 divided by 4 is 125 mils of lemon juice. Oh, didn't like that one. Anybody got that one? Maybe now, because I'm doing this way, doesn't mean to say it's the right way. I know I've got the right answer, but you might look at some of these that I'm doing and thinking, why didn't you do it that way? Yeah. Why didn't you just divide 600 by 1,000 and then multiply that by that? There's many ways to do these things. Leon runs 10 kilometers in 49 minutes. And don't worry if you struggle on some things. It doesn't matter how long you've been doing this, whether you've been doing it for 6 weeks or 26 years, you can still look at a question and get confused. It's just the way it is. Leon runs 10 kilometers in 49 minutes. Assuming he runs at the same speed, look, there's that assumption. How long will it take him to run 18 kilometers? Well, if it takes him 49 minutes to run 10 kilometers, that will be 4.9 minutes per kilometer. So now we're going to run 18, so that's 4.9. Multiply that by 18. Get the calculator out. 4.9 times 18. You'll always get to use the calculator in these. And that's 88.2 minutes. Now they've not asked us to change that into hours and minutes. So 88.2 minutes will be fine. Right. Shrishti collects the following information about train fares and journey distances. She says the distance of a train journey and the price of the ticket are directly proportional. Is she correct? Right. So, it's going to cost so much a kilometre. So, let's do the first one. So, you go 16 kilometres and it costs you £4. And that means it's cost you £4 per kilometre. The second one, you do 32 kilometres divided by 8, which is again £4 per kilometre. The third one, 64 kilometres divided by 12. 64 divided by 12 is £5.33 per kilometre. We'll do the last one anyway. 90 divided by 18. 90 divided by 18 equals 5. So this is costing £5 per kilometre. So, is she correct? No. Explain your answer. £4, £4, £5. Maybe the farther you go, the more expensive it gets. Right. To be directly proportional should all be the same. Same is there, but it's, let's go there. Oh, there it is, same. Alright, we got another one? Oh, no more. Right, so there'll be a worksheet on these that I'll find for you to do, and that's the end of this little direct proportion one, so I'll see you in the next one.